as you're logging in, you should see a picture of a very large animal, large tusks, and that's the Children's Natural History Museum. And we are at the corner of Eggers and Fremont. We're right across from Washington High School. The museum is closed right now. Hopefully we'll be able to open soon, but this is usually where you would come for your field trip. And I am here in the classroom, and I have all kinds of things around me. Look, I even have this. Ooh, can you make a guess as to what this might be? So I've got all things around here are next to me. Oops, that are from the classes that we use. So when you come here and do classes, you get to touch things, play with things, do hands-on, and do our experiments and explore the museum that we have upstairs. Now, again, as you're just logging on, class is going to start at 10 o'clock. Dr. Bluford will be doing class today. And you are going to be all muted when you first come in, but then we will ask for questions and answer and give you some answers again at the end. We have our topic today is all about weather. All right, so everybody's logging in all at once. So again, welcome to class today. We'll be starting at 10 o'clock, just a few minutes. Today's class is all about weather. As you're coming in, we do have everyone muted. And if you've got parents helping you log on, you should be able to see a screen that says Children's Natural History Museum. And you should see me, a little square talking. My name is Debbie. And if you want to do the speaker view thing, parents, if you want to help them do that, you can, but you don't have to. Main thing is to be able to see this screen that's in front. And again, we will be starting in just a few minutes. It says unstable. Internet connection is unstable.
It's going to be live today.
All right, well, we might be having a few internet connection issues today on our end, but hopefully that will work okay. We might have a few delays, but again, welcome to class as you're just logging in. My name is Debbie and welcome to All About Weather with Dr. Joyce Bluford. We will be starting in just a few minutes. Let our last few people log in. So as you're logging in, you should see on your screen, welcome to Children's Natural History Museum.
Okay, guys, we're going to start in just a few minutes. It is almost 10 o'clock and we're almost ready to start our What is the Weather? We'll have some demonstrations for you and we'll try for you to understand why the weather is so weird. Okay, now my name is Dr. Joyce Bluford. I'm a scientist who studies rocks, and that's called a geologist. But geologists also have to understand all about climate and weather because it affects our Earth. And we will find out exactly how that works. So most kids call me Dr. Joyce. So without further ado, let's find out what makes the weather. Now, California usually doesn't have very severe weather. So we would not hear things like this. What is that sound? It's a rainstorm. The rain is coming down, and in the background you can hear lightning. Now, have you ever thought what makes that actually work? Well, this is what we're going to explore today. We're going to find out that it has everything to do with water and how water goes through different stages on our Earth. So today we're going to learn the following. We're going to look at the states of matter of water. We're going to look at solid, which would be snow. We're going to look at liquid water, and we're going to look at gas. And as that goes around the earth, on the surface of the earth, and how it creates weather. We're going to look at temperature. Now, temperature is something that we feel on our skin, on our face. This is something that is actually real. And we're going to see how temperature can control how that water moves on the surface of our earth. We're also going to look at the atmosphere, the layer around our earth called the atmosphere that has all these gases in it and creates our weather. Because the weather, if you go out into space, there's no weather. But close to our earth, within our atmosphere, that is where our weather lies. And we're going to look at different types of weathers. We're going to look at hurricanes, tornadoes. Now, if you look right next to you, what is that thing happening right here? This is called a tornado tube, and we're going to try to explain how that works. Now, we're lucky here in California. We don't have all these things because that little twirly thing can be very, very destructive when it does occur in different states. Again, we are so lucky here in California, except we don't have as much water as other places. Now, so without water, you do not have weather. Water is very, very important to this whole cycle. So we're going to learn a little about the water cycle. The word cycle means it keeps going. So it goes, we have the word evaporation. So if you have water, the water evaporates because of higher temperature. It goes up in the clouds and gets stuck in the clouds. The clouds are another form of water. And then when it gets too heavy, it precipitates and comes down. And so you have this whole cycle of water. Without water, you would not have life. Water is a miracle. And it's very, very important. And we're going to learn that it is made up of two things, hydrogen and oxygen. Now, you've probably heard of oxygen because we bring that in into our lungs. We need to have oxygen to live. But water is H, which is hydrogen, 2O. And we're going to learn more about this very, very important molecule. Now, I want to read a little story or a little poem about Drippy the Hippie, and it kind of explains how the water cycle occurs.
Drippy the Hippie by Cassie Fries, animated by Doris Rayer and August Volting. This is a little story about a little hippie that goes through the water cycle. I have a very busy life and I'm always on the go. I'm part of the water cycle. It's really cool to know. The gases, hydrogen and oxygen, are what I am made of. I am clean and I'm fresh, and peace is what I love. I am a groovy raindrop. My name is Hippie Drippy. Colorless and tasteless. I'm not your average hippie. I live up in the sky till the clouds turn dark gray, preparing for my trip. I wait for rain each day. I put on my favorite shirt, it's colorful and tie-dye. I wave to the clouds to say to them goodbye. I am a groovy raindrop. My name is Hippie Drippy. colorless and tasteless. I'm not your average hippie. I fall from the clouds and land in a lake with many other drops. I really precipitate. I vacation here for a while, relax and get some sun. There are many drops who come to the lake for fun. I am a groovy raindrop. My name is Hippie Drippy, colorless and tasteless. I'm not your average hippie. I swim in the lake and party with the fish. I wait to evaporate. It's the clouds I really miss. As a gas, I will rise and travel really high back to the clouds, up into the sky. Condensation will happen. I'll go back to the state of being a raindrop waiting to precipitate. I am a groovy raindrop. My name is Hippie Drippy, colorless and tasteless. I'm not your average hippie. I am a groovy raindrop. My name is Hippie Drippy, colorless and tasteless. I'm not your average hippie.
So that's one of the things that I kept repeating in the song, colorless and tasteless. Pure water has no color. It should be clear and it is tasteless. It's just refreshing to our body. So our next, so we're going to look at our states of matter. How does water change? If you think about it, water, H2O, is the only compound on Earth that is in 3 different states all the time. In the Arctic and the Antarctic, it is in snow and glaciers. It is solid ice and in snow. Then on most of the Earth, especially in the water and lakes, then there's liquid and then there's gas in our clouds. So it is in all these forms of matter and it can change quickly. So like if you have a pot of water on the stove and you put heat underneath, what happens? All of a sudden it bubbles. Now, why is it bubbling? Because it's heating on the bottom, and as the it gets less dense, so the molecules get farther apart, and then at the top it'll start coming up as gas. And so this is one of the only compounds on Earth that does this easily. And without that ability to do that, we would not have our weather. So now, one of our activities that you can do so we make sure you understand what H2O is all about is, my molecule. Okay, so we're going to make this molecule here of H2O, and Phoebe's going to show you how it's all about. So let's take a look at how to make one of these molecules. Okay, so here's Phoebe explaining how to do it.
Today we're making water molecules on a stick. So first you're going to have a worksheet with 3 water molecules on them. I've already cut 2 of them out, just like this. So you can color in the water molecules with a marker or color pencil, and then take it and use a piece of tape and tape it to a popsicle stick so it looks like that. And once it's on the stick, you can use pom-poms or cotton balls and stick them onto the diagram. Make sure that your oxygen, which is the one in the middle, is the biggest one, while your 2 hydrogens on the sides are smaller. So once you have that glued on, you can repeat the process to make 2. And then we're going to make a little home for them using 2 index cards. So you have 1 full index card and cut the other one in half. Then use some tape to tape them together to make a little pocket, and tape your 3rd water molecule onto the top. So now you have a little holder for your water molecule.
Okay, so this is something that your teachers have the worksheets. You'll either get them, they're online, your teachers know how to get them. And so you're just kind of trying to realize that if you look at this little molecule is that the 2 H's, and we can call them, they're like our little ears, but they're ears like a teddy bear, so they're smaller. Hydrogen is smaller than the big face, which is then called oxygen. So this is one of your first activities, so you can understand this beautiful molecule. Okay, so let's continue on. Now, remember, the water cycle goes around and it cleans, because when water evaporates, it evaporates as H2O. But as you know, like, you can have water and you can put stuff in there and it'll dissolve in there. So our water cycle is doing something to clean our water to make sure that we have clean water. Now, if you look at the little dinosaur, what is the dinosaur doing? It's behind the bush, and just like any living creature, it's doing what? It's going to the bathroom, it's peeing. So as you can see, we have this water molecule coming down. Now, you don't want to drink pee, do you? No, but how does our water cycle through the weather actually creates clean water? And so when it evaporates, what happens? It's fresh water. And then we can reuse it over and over again. This is what makes water so miraculous. It's really a miracle that we have water. Now also look at that snowman there. What's the little doggy doing? Uh-oh, doggy is peeing on it. And remember, the pee, when it comes from a body, is usually warmer, so it's melting the poor little snowman. But then the snowman, if it gets colder, will start that cycle over and over again. Now, this is what the water cycle. So when I was reading the story about Dippy and Drippy, these are, I want to make sure you know these words: precipitation, evaporation, condensation. So the water starts as liquid. It, with temperature, evaporates. Then it goes to condensation and then precipitation when it comes down. This is important to our weather. Now, the water cycle. I want you guys now to understand these 3 very important words. And so we have another activity for you to make a water cycle. Now this water cycle is, let's take a look, and Phoebe will show you how to make this.
Today we're making a water cycle wheel. So first we have our worksheet just like this right here. And we can, wait, sorry, do you want them to color?
What happened? Okay, so what you're doing is you're just making this little water wheel here. And it is, again, this is your teachers have the worksheet. The worksheet looks like this. And then you'll be able to cut it out and learn those 3 words. What are those? It is evaporation, condensation, and precipitation. Okay, now temperature. Temperature is important in all of this. Why is it important? Because temperature is what makes these go through all these different solid, liquid, and gas. Now, what is temperature, guys? You guys have seen a, what is this, guys? This is a thermometer. A lot of times you might get a digital thermometer where it tells you. But if you notice on these that on when it's really solid and cold, That's the first one there. Look at the temperature is like 0 degrees. And so the molecules, the H2Os, are moving very slowly. And so that is when it is cold. So basically, the thermometer is cold and it keeps the temperature down. Now, as it warms up, the molecules can move around a little bit more and the temperature gets higher. And then when it gets into the gas phase, the molecules are even farther apart. And that has to do with that water cycle. So temperature really controls what form of water you will be in. So now what is this a picture of, guys? Do you see this rotating? What is that? What is that? Is that where we live on? Yes, that is planet Earth. And planet Earth gets radiation from the sun. Now, the reason why we get different temperatures is because of our atmosphere. As the photons from the sun come into our atmosphere, it actually kind of heats things up. That's a little more complicated, and you'll learn that in first and second grade, as this will start heating up different areas. So different parts of our land and water has different temperatures. Now, for instance, have you been to the beach? Of course you have. On a very hot day, the sand is hot. But what is the water? The water is cooler because it takes longer for water to build up that heat. So there's different temperatures changes on our Earth, and that makes a big difference. And it causes the weather. It does. How does it cause the weather? Well, let's take a look at this Earth. Now, here we are, and let's see if we can coordinate. This is the Pacific Ocean. The Pacific Ocean has water in the north and water in the south. Then when you go from the Pacific Ocean, you go to the Indian Ocean, water and land. You go to Africa, and you have Africa has land, and Europe is land. And then you go to the Atlantic, you have water and water. Wait a minute. Which is the only one that has land on the top and water on the bottom? The Indian Ocean. India is where where our weather starts because of the temperature difference between land, which would be India, Russia, China, that area there, and the Indian Ocean, which is land. This causes a big difference in our temperature in the atmosphere. And this is actually where our weather starts. And then as our weather goes from India to the Pacific Ocean to North America, where we are, and then to the Atlantic Ocean, and then it goes around the Earth. And so this is how a meteorologist or a scientist who studies weather starts predicting the weather. We look at temperature, we look at a lot of things, but this is very, very important how temperature very predicts our weather. So now this thermometer, look over to the right. What's happening there? Notice that the temperature rises, and we collect a lot of information on temperature. And you can do this at home. Now, all you'll need is, and our little experiment that you can do outside, you'd need a thermometer like this, or even if you have a digital, but this is what you can do. We do this with the kids to collect data, to see how it changes during the day. Now, Phoebe is outside and she's going to show you how to do this little experiment.
Thermometers like these two are really important for collecting data about temperature, how hot or cold something is. So for this experiment here, we have two containers with two thermometers, one with dark sand and one with light sand. So you want to make sure the thermometer is underneath the sand and then place them outside where the sun is shining directly on them. So you want to see where the light is coming from and make sure that the thermometers are right there. And then we're going to come back and check the temperature and see if there's any difference between the two sand colors.
Okay, now, why do we have the dark and why do we have the light? This is to show you that the sun can be coming down in the same place, but it will react different with different colors. So like if you're wearing black, you will absorb heat and the thermometer will go higher. If you're wearing white, the white reflects. So the light comes on you and reflects out and you become lower. But also, if you want to get really cool, you can make one of these water and see how long it takes for water to heat up. And you'll find out that water takes the longest. And that's what it goes back to, understanding this weather. Now, so look at the thermometer. So what is the temperature? When you start, you could put them out like this. You can have 20 degrees. That's when you're starting. And then if you look at the next one, 20 minutes later, can you read the thermometer? The black is now 40 degrees and the white is only 25. That's pretty cool that just different colors can make a big, big difference. Okay, now let's look at this envelope of air. Because remember I told you that we have weather not in outer space, but where do we have it? We have it inside close. Now, do you see this where the little light is coming down? It's hitting our atmosphere. So this atmosphere is just a small part. Now, if you look at the picture on the right, there's a word called troposphere. Troposphere. Let's say that word, troposphere. Troposphere is where our weather occurs. And this is an important part because past the troposphere, we don't have clouds. Whoa, isn't that cool? So that means like when a spaceman goes out into space, that's why he has to protect themselves because we have to bring our atmosphere with us. Now, let's kind of continue on here. Now, it's all broken up. And if you notice at the end there, where the little spaceship is, that's the exosphere. And that goes to where there is no atmosphere at all. Now, clouds. Do we see clouds out in space? No, but we see them in our atmosphere. Are there different types of clouds? Have you looked up, when you go out, look at the clouds. And I'm going to show you a different activity so you can understand these clouds. These clouds all tell you something. You can be your own meteorologist by going out to see whether you have stormy clouds, or you have puffy clouds, or you have these cirrus clouds, these little spikes up in the time. And this is an important part of understanding our weather. So all the pictures here, you see the word nimbus, stratus, and let's learn a little bit more about clouds.
Clouds by Michael J. Dougherty, animated by Doris Rea and Hagos Tawaldi, read by Phoebe Chen. Cumulus clouds fly puffy and white. Some look like cotton balls, fluffy and light. The nimbus clouds fly dark and low. When you see them, it means rain or snow. Cirrus clouds are the wispy ones, and they sure can fly, like icy mare's tails, high in the sky. Stratus clouds have a layered look, stacking clouds as if a book. Fog is the lowest cloud you see, maybe a cloud that got caught in a tree. We thank Luke Howard for their name. Cloud identification is an easy game. The end.
Okay, so now how can you make a cloud data chart? Now, Phoebe is going to show us how you can make this your own little guide. And so you can use, you'll be using the little cotton balls. And again, your teachers have this activity. The activity is, looks more like this, where you can then color it and you can put the puffy balls. And when you go outside, you can tell if it's a cumulus, stratus, cirrus, or nimbus. Okay, Phoebe, tell them how to do it.
Today we're making a cloud chart. We have our cloud chart worksheet just like this, a piece of construction paper, some glue, either glue stick or liquid, and cotton balls like this. So we're going to follow the different shapes by grabbing our cotton and stretching it and then gluing it to the sheet with our glue. The pieces that look more stretched out and wispy, you can pull the cotton apart so it's thinner, and then use our glue, put it on the paper, and stick our cotton on. And once our cotton is on, you can use a piece of tape or more glue to glue your chart onto a piece of construction paper, just like that.
So this is a way in which you can take it out with you and look up into the sky and see what clouds. Sometimes though, in California, we don't have any clouds. Sometimes we have something that a lot of other states don't have. We have a lot of fog. And remember, in the little book, a fog is really just a lower, um, cloud. And again, that's caused by the temperature change. Okay, now wind moves all of this. Now let's take a look. If you can look quickly at the Earth. The Earth has movement all over. Not only are we rotating on our axis, but this wind also goes from, and you've probably heard the word high pressure and low pressure. Low is when it's more colder air. The high pressure is where the air is out. And we have this movement of our atmosphere, just in the same way as the water goes around. Now, let's look really quick at what kinds of weather we have. So look at this, guys. This is a tornado. This is when, if you remember on this little demonstration here, watch over here, and you can see it building up, and then it starts twirling the air around. That can cause a lot of devastation. And this is all because differences of temperature. Now let's take a look at a hurricane. Oh my God, look at that wind and those palm trees. Hurricanes are these great forces. Now this is the United States has a lot of hurricanes. Where? Down in the Gulf of Mexico and Florida area. Again, that's caused because you have warm tropical water in the Gulf and then cooler on the land. But this can create ways in which this wind and the water interact. Now, also in India area and Indonesia and going up toward Kamchatka toward Alaska, you get these huge differences. And these are huge cyclones, which is much, much bigger than a hurricane, but goes through that twirling of the differences of temperature. Now look at what happens. A lot of times you get too much rain, and that can cause flooding, and that causes other damages because it depends on where that evaporation is occurring and getting a lot of liquid in those clouds. And then if it keeps raining and raining and raining, this is what you get, disasters. Okay, then you have blizzards. So you have too much moisture and it gets cold. What do you get? Too much snow. And if you remember down in Texas, this is what happened. We got some very low pressure and very cold temperature, but moisture from the Gulf of Mexico, and it all makes a mess. Okay, here in California, we have another problem. We have not enough rain. And so we get something without water, and water is important for our very survival. So now, so our atmosphere, let's just get this together. So, and then start thinking about questions you might want to ask us. The atmosphere has when the ocean and land interact, and it creates the weather. And the weather changes all around the earth as the earth is rotating, and it creates a way in which we can see these patterns. Because a meteorologist, like I said, a scientist who studies weather, they look at this prediction, they look at the weathers, they look at the layers, and they can predict very accurately what the weather will be. So with that, guys, we will see if you have any questions.